Good morning. This is Kasturi Day. Today I'm going to again continue with the discussion of hydrogen chapter according to ICSE syllabus class 8. It's a chemistry chapter. Okay. So I was discussing in my last video the introduction of hydrogen, occurrence of it, and how it is prepared. So first process was electrolysis, and the second process is by the action of dilute acids on active metals. Okay, how this hydrogen is prepared by the action of dilute acids on active metals. Okay, metals like magnesium, zinc, iron, etc. They react with dilute HCl or dilute H2SO4, that is hydrochloric acid, dilute hydrochloric acid, or dilute sulfuric acid, to liberate hydrogen gas along with the formation of their respective salts. Okay, so when dilute hydrochloric acid or dilute sulfuric acid acts on magnesium, zinc, or iron, etc., other metals, they will liberate a reaction takes place, and with that will liberate a hydrogen gas along with their respective salts. Okay, like magnesium, when react with dilute sulfuric acid, it forms hydrogen, that is liberates hydrogen along with magnesium sulfate as the salt. Okay, then zinc, when react with sulfuric acid, it forms hydrogen gas as well as zinc sulfate as the salt. Then zinc, when reacts with hydrochloric acid, it liberates hydrogen along with zinc chloride. Then iron, when reacts with hydrochloric acid, it liberates hydrogen along with iron chloride, ferrous chloride. Okay, then the lab preparation of hydrogen, how hydrogen is prepared in the laboratory. That is prepared by the action of dilute hydrochloric acid or dilute sulfuric acid on granulated zinc. Okay, I will tell you why granulated zinc is only used in the lab preparation of hydrogen later on. Okay, so let me first discuss the preparation of hydrogen, the process rather. Okay, the granulated zinc is used, it's because it contains an impurity, that's copper. Okay, that acts as a positive catalyst for the reaction. Okay, so that is why granulated zinc is only used in the laboratory. Okay, so because it has impurity, that's copper, that acts as a catalyst for the reaction, positive catalyst, that is, it enhances the reaction. Okay, the process or the reaction process makes it faster. Okay, so that is why this granulated zinc is used, because in the laboratory the time limit is very less. So for this experiment, a few pieces of granulated zinc is taken in a round bottom flask. Okay, then a two-bored airtight stopper is fixed at the mouth of the flask. So a round bottom flask is taken in which some granulated zinc is kept. Then a stopper is used to at the mouth of the flask, which has two bores in it. Okay, from one bore a Thyssen funnel is passed through. Okay, and through another bore a delivery tube is passed through. Okay, now the other end of the delivery tube, one end is bored inside the flask, this round bottom flask, and the other end of the delivery tube is passed inside a beehive cell, which is kept in a trough containing water. Then some dilute hydrochloric acid is poured through the Thistle funnel. One Thistle funnel is present in the round bottom flask and passed through the bore. So from that, through that Thistle funnel, dilute hydrochloric acid is poured. After, when the dilute hydrochloric acid reaches this granulated zinc, of brisk effervescence is seen. Okay, which indicated the liberation of hydrogen gas. Okay, so the first few bubbles of the gas is allowed to escape. Let it escape. Okay, then a gas jar, this hydrogen gas will escape through the delivery tube. Okay, so first this some of the bubbles, let it escape, And after that, this then a gas jar which is completely filled with water, that is inverted over the beehive cell. Okay, now hydrogen will displace water and will get collect on the in the gas jar. That is, this process is known as downward displacement of water. See, there will be a trough on which there is a beehive cell. A delivery tube is passed through this trough into the trough, and it is covered by the beehive self, and the beehive self has a this one some gap in between, okay, a hole, and over that hole this gas jar which is filled with water will be inverted. Okay, so and the hydrogen gas which is coming out through this delivery tube passing through this water will collect over the gas jar. Okay, it will displace water and will collect over the gas jar. Okay, see, from the picture you can see this is the round bottom flask. There's a thistle funnel through which the dilute hydrochloric acid being poured. There's a delivery tube which is coming out from the this round bottom flask, and then it's going through the beehive self into the trough through the beehive self. Okay, into the beehive self, and then a gas jar is over inverted over the beehive shelf, and the gas which is coming out through the delivery tube will come and collect over the water in the gas jar. Okay, now some precautions have to be taken while collecting this hydrogen gas. Okay, so we should not collect the first few bubbles of the hydrogen gas. Why? Because they may not contain, they may contain air too. Okay, which is present in the flask and the delivery tube. So that inside the round bottom flask or in the delivery tube, there's some air present, and that may get collected over the this gas jar, inside the gas jar above the water. First few bubbles. Okay, that's why the first few bubbles are allowed to escape. Okay, then we should not bring any flame near the apparatus, because hydrogen is inflammable, it will catch fire. So we should not bring any flame near the experiment. Okay, then certain notes are there. See, hydrogen gas is sparingly soluble in water. It's very less soluble in water, so it can be collected over water, but it picks up moisture. Okay, it becomes hydrated, the gas becomes hydrated. So when it is collected over the this gas jar, over the water inside the gas jar, it may collect moisture. So dry hydrogen gas is obtained when it is passed through when it is collected over mercury. Okay, if we collect this hydrogen gas over mercury instead of water, then we can get dry hydrogen gas. Okay, see, as hydrogen gas is lighter than air, it is collected by downward displacement of air also. Okay, but it is not safe. It can be collected by downward displacement of air because it is lighter than air, and it will rise above the air level. Okay, but it is not safe. Why? Because the mixture of hydrogen gas with air can lead to an explosion. That's why it's not collected over air. It is collected either over water or over mercury. Okay. See, next is this another note that dilute nitric acid is not used here. Why? It can be dilute hydrochloric acid, or you can use dilute sulfuric acid. But why not dilute nitric acid? Because nitric acid is a strong oxidizing agent. Even when it is dilute, this nitric acid is a strong oxidizing agent and can oxidize hydrogen gas and convert it to water. Okay, and it will defeat the purpose. The purpose will not be solved. That is, hydrogen gas will not be obtained. Instead of that, water will be obtained. So dilute hydrochloric acid or dilute sulfuric acid do not oxidize hydrogen into water, and that's why they are more preferred than nitric acid. Okay. But a very dilute nitric acid can react with magnesium or manganese, okay, to produce hydrogen. Very, very dilute if it is used, this nitric acid, then it can give hydrogen gas. Otherwise, it's a very strong oxidizing agent. So it's preferable that we use dilute hydrochloric acid or dilute sulfuric acid as for the preparation of this hydrogen gas. Okay, hydrogen gas can also be prepared from cold water. The very active metals like sodium, potassium, and calcium, they liberate hydrogen gas with from cold water along with their metallic hydroxide. Okay, that's why what happens as the sodium and potassium, they are very active metals. They react violently with water, while calcium reacts comparatively slow, and that's why sodium and potassium, they are not kept in direct, they are prevented from direct contact with water or water vapor or even air. Okay, and that's why they are stored in kerosene oil so that they cannot react with the water. Okay, so see, metal plus cold water, that gives us metallic hydroxide and hydrogen. Okay, the sodium plus water gives us sodium hydroxide and hydrogen. That's a very fast reaction. Even potassium also, calcium forms calcium hydroxide and hydrogen, but comparatively slow. So from what hot water, magnesium liberates hydrogen from boiling water. Okay, and that's reaction is a slow one. Then from steam, if magnesium, certain magnesium, zinc, aluminium, iron, that they liberate this metallic oxide, okay, that and hydrogen, if steam is passed over these metals. Okay, and that metal should be heated one, hot metal should be used. Okay, okay, like there's magnesium, then zinc also, when hot metal, that is hot zinc with water and steam, and even aluminium with steam, then red hot iron with steam. Okay, these metals other than zinc are not used in the laboratory. Why? For the preparation of hydrogen gas, because sodium and potassium, they are violent. Okay, I told you they're very violent in their reaction. Then calcium and magnesium, they're expensive. Even aluminium, they have an affinity towards oxygen. Aluminium has a great affinity towards oxygen. And then when the reaction starts, it forms a coating of aluminium oxide and the reaction does not proceed further. Okay, and the hydrogen is not produced after reacting for some time. Even iron, that needs to be heated very much. Okay, and the reaction is a reversible reaction, that's why it's not used in laboratory. Lead, it is insoluble, forms an insoluble chloride and sulfate salts with dilute hydrochloric acids and sulfuric acid and stops the further reaction. Given copper, mercury and silver, they are below the activity, below in the activity series, below hydrogen, and that's why they cannot produce hydrogen from the dilute acids, and therefore they are not used in the in this laboratory. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. Please do like the video, share with your friends so that they can also be benefited from these videos. And do subscribe to get the notification of my next video. And also that will encourage me to produce some more good videos for you. Okay, so thank you for watching and have a good day.